Hi everybody, this is Dr. Nirmala Krishnan, Professor, Department of Chemistry, Dr. MGR Educational and Research Institute. Today, I am going to talk about the virtual lab on EMF, that is electromotive force. What are all the objectives of this experiment? In this experiment, we are going to find the EMF of the cell. Using the EMF of the cell, we will be able to calculate the Gibbs free energy change of a cell reaction. We will be able to calculate the equilibrium constant and to predict the spontaneity of the cell reaction. Now, what is EMF? The difference in potential which causes the flow of current from an electrode of higher potential to another electrode of lower potential in a galvanic cell is called the electromotive force or EMF of the cell. The unit of the EMF is measured in voltage. Now, what is the theory behind it? The electrode at which the oxidation takes place is known as anode, and the electrode at which reduction takes place is known as cathode. When a metal is in contact with its own ion solution, it develops a potential with respect to the electrolyte. The potential difference developed at the anode electrolyte interface is called oxidation, and at cathode electrolyte interface is called reduction. The potential difference between the anode and the cathode is called EMF of the cell, and which is measured at standard condition, that is 1 atmospheric pressure and 25 degrees centigrade is called standard electrode potential. Standard electrode potential gives the tendency of the electrode to either get oxidized or reduced. If the electrolytes are different, the two compartments are joined together by means of salt bridge, which is a tube containing concentrated electrolyte solution in agar jelly that completes the electrical circuit and enables the cell to function. Now, what is EMF series? A series in which the metals are arranged in the decreasing order of the reduction potential is known as EMF series. So, the reduction potentials for various metals are given in this table, which you can refer. Now, how to measure the EMF of the cell? By convention, we compare the reduction potential of all electrodes with respect to each other, and the reduction potential of right-hand electrode, that is cathode, should always be higher than that of the reduction potential of left-hand electrolyte, that is anode. So, the EMF of the cell is represented by E cell is equal to E right-hand side minus E left-hand side. So, by considering galvanic cell as example, anode is zinc and cathode is copper. The galvanic cell is connected by means of a voltmeter, and the two solutions are connected by means of a salt bridge. And the right hand side cathode is copper, whose standard reduction potential is 0.34, and the left hand side is zinc, whose standard electrode potential is minus 0.76. So, E cell is equal to ER minus EL, which gives plus 1.1 volt. So this is the virtual lab which you are going to do. Here the temperature is given, you can change the temperature. Cathode, you can select the electrodes from various electrodes are given. So you can select it. Anode also various electrodes are given. So I can select the anodes. Okay. So when you select the cathode and anode, it will be reflected here and you can measure the EMF here. And the concentration you can change of the electrolytes. So this is copper sulfate and this is zinc sulfate, and you can change the concentration also. So all these things you can change. Temperature you can change, cathode you can change, anode you can change, concentration you can change, and the result you can see here. So I will show you an example. So copper you can keep it as cathode, anode you can keep it as zinc. Now concentration you can keep it somewhere around 2 point something you keep it. So result you see 0.950 is the voltage which you have measured. So this is about the EMF measurement experiment. Very simple method. Applications already we saw. Okay. Hope you understood. Thank you for watching. Thank you.